Hi everybody, my name is John Bellameric, and today I will be giving you a brief overview and demo of Nephio. This video is intended to be pretty succinct, so there will be a number of other videos coming out in our learning series, Learning Nephio with R1, and so if you don't follow everything, that's just fine. Drill into those later and try out the demo environment yourself. So the place I'm going to start is with talking a little bit about what we've actually delivered in Nephio R1. Essentially, we had three user stories that we wanted to achieve. One is deploying 5G core network functions from Free5GC, and then user stories 2 and 3 were showing how we could upgrade the control plane capacity and the user plane capacity and the control plane capacity. And we were able to achieve all of those user stories, but we also took it a step further and achieved a number of our stretch goals, which includes provisioning all the rest of the functions. There's quite a few of them, we'll see in a minute. And more interestingly, provisioning the workload clusters themselves. In Nephio, we tend to divide clusters into a management cluster, which is where all the Nephio controllers and other things run, and then workload clusters that run your actual network functions or other workloads. So we're able to provision those workload clusters and have them join Nephio and come under management. We also built some UI viewers for some special new resources we built, and we're able to actually, once we provision the entire network, we're able to show how we can simulate a call through it using the UE ransim tool. Underlying all of those, in order to implement all of those use cases, we had to build a number of general purpose package or configuration management type of functionality. This is really a lot of R1 is focused on this. Nephio is more than this, but a lot of R1 is focused on this. The key concept here is that we take our intention, whether that's infrastructure, like we want to have a cluster here or a cluster there, or that's workload, we want to have this network function running on that cluster, this network function running on a different cluster. They're all bundled into what we call packages, which are really just collections of Kubernetes resources, or at least what we call KRM or Kubernetes resource model entities that capture that intent, so machine readable entities. Then we enabled a bunch of functionality where we can take those packages, those bundles of intent, and we can sort of clone them and tweak them and modify them so that they become specialized for a particular instance in a particular cluster, but maintain their connection to their original source so that changes in the original source can be propagated across all of those individual instances of packages. So we'll get much more into that in later videos. So as a reminder, the scope of Nephio is divided into what we call 3 swim lanes: infrastructure, workload or network function, and workload configuration. And in R1, we're able to demonstrate a little bit of each of those. In the infrastructure lane, we demonstrate cluster provisioning. In the workload lane, we demonstrate provisioning a bunch of network functions, as well as some supporting workloads that those network functions need. And finally, in the third swim lane of the workload configuration, we built a Kubernetes operator, which takes an intent for a UPF, an SMF, or an AMF. So it takes a Kubernetes resource that sort of represents the basic configuration, but is not specific to Free5GC, and that gets delivered to a workload cluster, and an operator running on that workload cluster uses that intent to render the deployment, the service, and also the configuration file or config map for the network function. So it's actually generating, it's a Free5GC specific operator that's generating the specific configuration that that Free5GC function needs at runtime. So what does the Nephio environment look like? What we're going to look at today is a sort of self-contained single VM environment. The idea here is to make it easy for people to download it, play with it, try it. So there's a set of exercises you can go through. We're going to go through a couple of them, but there's many more you can go through on your own. And what that single VM environment contains is a management cluster to start. Normally that would be in a production environment, that would be a real cluster with many nodes, and but for our purposes, for demonstration, it's easier if we just put it all in a VM and we run it in a kind cluster, Kubernetes and Docker cluster. So that cluster contains a number of Nephio components. That's what these are here. And it also contains a number of sort of placeholders for things that normally would be provided by an external service. So for example, we have Metal LB running in there, which is a load balancer service that would normally be provided by maybe your cloud provider's load balancer. We have Git, which is an open source Kubernetes, a Git provider running in there, which maybe normally would be done via GitLab or GitHub or Git, but maybe running in a cloud environment rather than in the same cluster. For cluster provisioning, we use Cluster API, which is an open source project from Kubernetes that allows you to provision different kinds of clusters. In particular, we're using it for kind clusters, but in a production environment, again, you might use Crossplane, you might use at Google, we have something called Kubernetes config connector that does this for GKE clusters, for example. The last piece we have represents is what we call our backend resource allocator. So what this represents is many organizations have systems or people or ticketing processes that allocate things like IP addresses, subnets, VLAN IDs, and we've built an IPAM system, a resource allocator system that can allocate IP addresses as well as VLANs, and we use that in our specialization process so that we can automate the allocation of a IP address based upon which cluster a particular workload may be landing on. So this is where you start. It's a VM with this environment. And then the next question is, where do we end? So what we end up with is actually not just the management cluster, but a set of workload clusters. One is we call a regional cluster, and we have a bunch of network functions running in that. You can see them all along the top here. And then we have two edge clusters. We only show one in this diagram, but two edge clusters running your UPF, and one of those edge clusters also is running a simulated UE and GNodeB. And then you can actually make a call through this. All of these IP addresses that you see on the screen, those are all allocated automatically through the tool, and they're all sort of part of the goal of Nephio is to separate the knowledge that the deployer needs to have versus the knowledge that the infrastructure team or many other teams have. So the idea is that the infrastructure team populates the systems with the available resources. The deployer deploys the system, and when Nephio picks which cluster a particular network function is going to land on, it can use the information, the sort of metadata that the deployers provided to say, oh, you want an IP address on the the VPC RAN network in cluster 5. Okay, it goes and looks up in the IP address management system and can use that metadata to allocate that particular IP address and configure it for that particular cluster. All right, so let's just jump right into the demo then.
Okay, so what you see here is the initial setup. We have a management repository, which is used to actually manage the workloads running in the Nephio management cluster, other than the sort of basic ones that we've set up already for as part of the initial installation. This other repository management staging is used as part of our cluster bootstrapping process. So what I'm going to do is deploy the regional cluster. And following the exercises that we have, I'm going to use the CLI to provision the regional cluster. So we can use the CLI, we can use the UI, there's different ways we can do it. The exercises give you a couple of different ways so you can try it. We can see that we have this management repository that, as I said, controls the workloads that are deployed to the management repo. And I want to deploy a package called the Nephio Workload Cluster Package. We can look at what is in this package. In in this package, we actually have reference to a number of other packages. So what we end up doing is installing a cluster package, installing a repository package, creating a VLAN, installing config sync, installing a CNI plugin in the cluster, installing a volume provisioner, installing a multis. So all of these things have to be done in order to get a cluster up and running and joined. However, it's all done automatically for us simply by deploying this cluster. So we want to take the most recent version of the package. Over time, we've had different versions of the package. So we want to take the most recent version. So what we're doing here is we're saying, let's clone this package, the most recent version, into the repository management and name it regional. So it created that particular package, and now we want to add some labels to that. So what we're going to do is we're going to pull out that package to a local directory, and that allows us to make edits to it. This is the same as going into the UI and editing the package in the UI, but we're doing it via the CLI experience. So what are we doing? We're going to run a kept function called set labels, and it's going to set these labels on all the resources within the package. Okay, so it's set 18 labels in total. Next, we want to push that. This is just done in our local environment, so we want to push that back to our repository. And then, once we've pushed that back to the repository, in Nephio, we use a package approval process. So packages are sitting in a draft form. We need to put it into, we need to propose it for approval. And then we need to approve that. And this will tell, once it's approved, then config sync will see it in the management repository, and it will pull it out, and it will start to actuate it. And we can see that it's been created. We have an automated approval controller so that we don't have to click approve a bunch of times for certain packages and when they're labeled in a certain way. And so that's saying that we'll approve it, but it actually waits a little while before it approves in a couple of minutes. So we'll just give this a few minutes. So let's take a look in the UI and see what's happening. I paused the recording for a few minutes, so some things have happened. What we can see is that the regional package that we approved is here. It's marked as a revision number 1 based upon V8. We can actually look at that and see what differences are labeling and things like that did. If we compare it. So, for example, looking at this one, you can see here's the labels that we added. There's some other things that changed compared to the upstream. So from example to regional. Regional is the name we gave it. Okay, but nonetheless, going back to that, what it's done is it's created some additional packages. A regional cluster package, a regional repo package, and a regional VLAN index package. So each of these serves a different purpose. The regional cluster package contains the actual cluster API resources for creating the kind cluster. The regional repo creates another repo in Gitee in order to serve as the destination for workloads that are bound for the regional cluster, and the VLAN index is for configuring our VLANs for that particular cluster, since it has multiple networks that are use VLANs. So our next step is, once we have the regional cluster we can check it out and take a look at what's running in it. It should be nothing right now, but to do that, we need to get the configuration file for the regional cube config file for the regional cluster. That's what this command does, and then we can use it in our cube control commands to see what's in the regional cluster. The regional cluster has machines associated with it. When I run this command without the cube config or the context, it's going against the management cluster. We can see that there's a single machine that's part of the regional cluster. It's actually not ready yet. It takes a little while, as I said. While we're waiting for that to come up, we can actually use a different method to deploy two edge clusters. So edge clusters are going to be deployed using something we call a package variant set. Package variant set is a way to make multiple instances of a package based upon some targeting criteria. So here's what it looks like. So it's a Kubernetes resource that allows you to automate the process we just went through manually. So for the regional cluster, we used kept and we made some changes. So this allows us to do that automatically. So what we're saying is that we're going to take that same package we used, Nephio Workload Cluster version 8. We're going to clone it into the management repository, just like we did with the regional cluster. And we're going to do that twice. One of those packages is going to be named Edge 01, and one is going to be named Edge 02. That will create two clusters, Edge 01 and Edge 02. Just like we did for the regional one, we're going to call the set labels on it, and we're going to use, in this case, site type edge, not site type regional. So in order to do that, we simply apply that resource to our management cluster. And when we do that, our package variant set controller will pick that up and start processing it. So let's see what it has to say about it. Okay, so you can see that's the spec that we just looked at. There's a bunch of other information about it, but in particular we're interested in seeing the status. The status conditions say that it's perfectly valid, that it's created all the package variants. So a package variant set generates package variants. A package variant is another Kubernetes resource that is used to do those actual commands that you saw us doing by hand, but it does them using the API. So we can look at what that looks like. These are the two that were just created. So edge clusters is the name of the package variant set. Management is the name of the repository, and Edge 01 is the name of the package. And so that's how package variant sets are named when they're created by package variants are named when they're created by package variant sets. These, by the way, are all the different package variants used and created by our initial regional one. So eventually we'll see a bunch of things like this, but for these individual edge ones. So let's look at one of these. This is a package variant, so we can say describe package variant. And we see again a bunch of information about it. In particular, we see it's valid and it has successfully created the downstream target. So this is a package revision. So a package revision, just like the original thing we cloned was a package revision. Now this is a package revision, but it's in the management repository. We cloned it from the Nephio example repositories. So then if we describe that, we can see what the status of that is. Okay, so we can see that it's here. it's been created, and it's waiting to be processed. It's going to go through some processing, and some of these, the age on this means this is old. These events aren't state. They're things that happened over time. So you have to look and see if there's a more recent one. What we can see in particular is that it's waiting for approval. So I'm going to pause the recording and come back in a few minutes. Okay. So you can see here, I looked at the machine sets. You can see that Edge 01 and Edge 02 have provisioned. Back in the UI, we can see that they are that we have now 4 repositories: one for managing the regional cluster, one for the management cluster, and one for each of the edge clusters. So those were provisioned all through that same process. We take one package, we clone it to a name for the cluster, and it automatically does a bunch of different things, provisioning all of these different packages that are necessary to actually create the cluster, join it to Nephio, and make it manageable under Nephio. The piece we don't do today is the intercluster networking between those. So we have some scripts that we run to make that happen. That's going to be done in a future release. So the next step then I want to show is deploying a workload across the different clusters. We will deploy the free 5GC control plane functions. We can use the user interface to do that. Because we've seen the CLI journey, we've seen the journey using the package variant set resource. So let's see how we do it using the UI. We're going to deploy this into the regional cluster. Here, this is the set of functions that doesn't require any real customization. So we don't need to go through the pipeline that's going to allocate different resources. Instead, we can just use our sort of standard process. So we're going to go from the free 5GC control plane. And we could just skip through all of these and say create deployment. So this is showing us our package that represents all the different resources that are needed in order to run those different network functions. You can see there's many different resources here for different network functions, and the web UI as well. We actually don't need to make any changes to any of these, so we simply have to click propose, and then once it's proposed, we simply have to click approve, and that will actually take care of deploying those, and we will see within a few minutes all of those show up within the regional cluster. We can do that by coming back here and looking at our regional. I have a special little function here. There we go. Okay, we can see that was created, the namespace for it. Let's see how the resources are, how the different functions are coming up. Okay, we can see that this is still coming up, but most of the things are up here, and the rest will come up within a few minutes. By now it's probably up. Yes, okay. So it's as easy as that to get all these individual network functions that don't require extensive customization done, and we can do it through the UI. All right, so that's all I'm going to demonstrate right now. There's a additional set of exercises that we'll go through, rolling out the free 5GC operator to the workload clusters, and deploying the AMF, the SMF, the UPF, deploying the UE ransom, showing the connectivity, modifying the capacity requirements for UPF, modifying the capacity requirements for an SMF, and those are all exercises you can do yourself by following the exercises in the user guide. Thank you very much.